laws of motion. Complete mechanics. Very fundamental of mechanics. Here, my voice is not very far. It will be clear. Tell me when I think it's a technical problem. It will be resolved within 1 or 2 minutes. Tell me, is it clear now? It's still not clear. Okay, wait. Let me do something. Everyone is going through. Is it audible now? Is it audible? There is a problem with the voice. Now tell me, what is the status of the sound, the status of the voice? Tell me, is it audible now? Everyone, is it audible? No, it's still not audible. Okay, I'm looking into that. Now tell me, I think it's clear now. Everything should be clear now. Tell me. Yes, sir. Okay. Okay, so now we will start. Okay, it's a wastage of time. I think 7 minutes we have wasted already. So we will do. Okay. So let's directly start. Newton's first law. Whenever we talk about Newton's first law, the first term that come to our mind is inertia. Is inertia. So I am not going in deep detail about that. What I am telling you is a simple term. In a simple language, how can you define Newton's first law? And Newton's first law says if net external force, net external force on a body is zero. If then its acceleration will also be zero. This is the Newton's first law. The statement is clear. What is the meaning of this term? If external force, all the external force contributes to zero force, then acceleration will be zero. For example, if I say, let's suppose there is a body like this. I'm not uh, putting the surface here. Let's suppose this is a body. And one force F is acting here, another is acting here, one is here, one is here. This is F, this is F, this is 2F, this is 2F. Now you can see that in this body, there are four external forces mentioned here. But you can clearly see that the forces in the X direction, this is and this one, these both forces are in the X direction and both are opposite direction. So the net force due to this is zero. You can conclude that net force in X direction is zero. Again, you can see that there is a two force, 2F and 2F in Y direction, but net force in Y direction is also zero because both are opposite. So clearly you can see that in both the directions, body has no net force. So acceleration in both the direction will be zero. Now the situation arrives where you can see, like, again there is a body. One force F is acting here, 2F is acting here, F is acting here, and F is acting here. Now you can clearly see that if I see in Y direction, if you see, there are only two forces. One is upward, one is downward. So net force in Y direction is zero. One is upward, one is downward. They both are opposite to each other. But in X direction, there are two forces. But they will not cancel each other because this is 2F and this is F. So force in X direction is what? F. In which direction? You will say in left direction or minus X direction. So clearly you can again state that this body will have acceleration in the X direction. This body will have acceleration in the X direction. The conclusion thing is that if body has some forces in any direction, it will have an acceleration in that direction. If the net force is zero, then acceleration will also be zero. Clear? Okay. This is the simplest thing of first law. Now moving further, what is second law? Second law has different statement as well. But right now what we are going to deal is net force, or you can say F external. F external is equals to mass into acceleration. This is the second law of motion, very famous. Newton's second law of motion, F is equals to mass into acceleration. Now the important thing here is again the same, that you should write always in terms of X, Y, and Z directions. Because in the previous slide, we have seen that there might be forces in different directions, someone in X direction, in Y direction, in Z direction. So for that, if you apply Newton's second law, you should consider the axis on which the force is acting. For example, if you talk about force in the X direction, it will be mass into acceleration in the X direction. That means you need to deal with the forces according to the axis in which they are acting. Similarly, if you write in Y direction, then it will become mass into acceleration in Y direction. Force in Z direction will be mass into acceleration in Z direction. Try to remember these. I will explain this at the later stage. First thing, Newton's second law of motion is this. How it can be applied or how is it applied? It is applied according to the direction of the axis of the forces. Or you can say along the axis we divide. We consider whenever you are writing in X direction, you will not consider forces, any force in the Y direction. You will not consider, and you shouldn't consider the force in the Y direction or Z direction. When we are dealing with force in the y direction, we will not consider about x and z. We will see, we will look only in y direction. Clear? Again, moving further. This is the famous law, third law. The statement is, I think you know every action has equal and opposite reaction. No need to write. This is action reaction. Action and reaction. What is the meaning of action and reaction? The important point is here. Action and reaction acts on different bodies. Acts on different bodies. If, for example, you know that if you hit a surface, what you feel, the impact you made on the surface, the same force the surface has exerted on you. This is the same thing. So action reactions, you have acted on the surface and surface has acted on your hand. So both are these action and reaction pairs and they both act on different bodies. Okay. Now, after this Newton's third law, what is our main purpose is to draw the free body diagram. This is the most important thing that you should learn. My recommendation is you should learn free body diagram. Free body diagram, what is the definition of free body diagram? Anybody knows what is the kind of definition or what is free body diagram? Say yes or no at least. No need to explain it. Just say yes or no. Okay. Okay. I think if I can pronounce your name, it's uh, it's uh, okay. Free body diagram. The representation of, listen, the representation of all the forces acting on a body is called free body diagram. The statement is clear. What is the purpose of free body diagram? The representation of all the forces acting on a body. For example, now learn. I think I think most of you don't know how to draw the FBD. This is the most important aspect. Now, first of all, first look at the first diagram. It says that body is at rest. Body is at rest and kept on a surface like that. Now, if you can see in the gravitation chapter, what we have seen that gravity or earth attracts everybody towards itself, and this force is known as gravitational force or gravity. So one thing is very clear, this mass m will be under the force of gravity. And what is the magnitude of this gravity? Earth pulls it in the downward direction. So one force that is acting on it is the mg. This is a certainty that whenever there is a body, there must be a mg force acting in the vertical downward direction. One thing is clear. Now, if you can see, feel it, if you put some object on your hand like this, what you feel, the weight of the body is felt by your hand. You can sense it. The weight of the body is felt by your hand. That means this body is doing some action on your hand. In return, this hand will exert a reaction. The hand will exert a reaction. So that reaction force is denoted by normal reaction, is denoted by N. So whenever there is a block, there is a one force which is mg downward and one force which is normal reaction. Now, if I tell who is the source of this N, this N is created by or this N is exerted by the surface. By the surface. Clear? So there are two forces on the block. Now, if I want to write the equation, if I want to write, it's not me who is saying the write the equation. Whenever you find a question, you need to write the equation. And what equation? That is Newton's second law. Which equation you need to write is Newton's second law. And according to that, what I have told you according to second law, that you need to apply second law individually in X, in Y, and in Z direction. So now here you can see there is no force in the X direction. So in which direction you will apply? In Y direction. If I apply the equation in Y direction, what it will be? Listen, now this is again a one important thing. You need to write net force in Y direction is equals to mass of the body into acceleration in the Y direction. Clear? The question says the body is at rest. That means it is not moving. So again, you can see, if I write it again, net force in the Y direction, there are two forces. One is N, one is mg. Now it's your choice, or if you want to make me a choice for you, then the choice will be like that. There is a positive X direction, negative X direction. Any force which is in the positive X direction will be taken as positive, which is in the negative X direction will be taken as negative. In the positive Y direction will be taken as positive, in the negative Y direction will be taken as negative. This is my recommendation, my sign convention that I use most of the times. So here you can see, if you can see, N is acting in the upward direction. Upward means it will be positive. Positive. Mg is acting in the downward direction, so it will be negative. Is equals to mass, and body is at rest, that means acceleration is zero. So what you can get, N is equals to mg. This is how we apply equations or second law of motions equation in free body diagram. Now that there is a variation in the question, I am taking a break of at least 30 seconds. If you want to ask anything about this free body diagram thing or the first statement or first question that I have discussed, you can ask. After that, I will discuss the second part. Acceleration thing. Okay. Question is saying that body is at rest. If the body is, or you can say, this is a simple situation. You have put the block on your hand. You have put the block on your hand. Can it accelerate? Without you applying some force, it cannot, it will remain at rest. You can see that. It will remain at, if it will remain at rest, then its acceleration is what? Zero. Okay. Now, in the second case, you can see that this force is not in the X direction, not in the Y direction. Can you see this? Whenever such situation arrives, when there is no clear-cut direction of force, neither in X nor in Y, then what you should do, you should resolve the force in its component. You should revolve the force in its component. Then what is the method of component? What is the method of resolving of components is, listen, from which axis the angle is given. The angle is given from theta axis. From which axis angle is given, in that direction, component will be f cos theta. And perpendicular to it, the component will be f sine theta. So what we did here, we resolved the vector, resolved the force in its two components. One is f cos theta, one is f sine theta. After that, you can clearly see that there is one more force acting on it, and that is for sure is mg. Mg. If mg is there, then there will be a normal reaction n. Now, it is also given that that block is moving with the acceleration a in positive x direction. It is given like that. Now we want to write the equation. You can clearly see that there are forces in x and in y as well. So if I write in x direction, this thing is everything in Newton's laws of motion chapter. Nothing else is is more important than this. Now, if I write the equation in x direction, can you see that there is only one force in x direction? Which force is F cos theta? F cos theta is equals to mass and acceleration of the body is given as A. A. This is the equation that we can write. In y direction, it can be written as how many forces are there? Two forces upward, one is downward. So you can write as upward forces as positive n plus F sine theta. Downward force is negative minus mg is equals to 0 because this body is not moving in y direction, is only moving in x direction as the question mentions. So n plus f sine theta minus mg is equals to 0. This is the second equation that you can form. After this discussion, we will move further for some more critical topic, more critical free body diagram like this. This is again a very critical situation. Not very critical, very easy. You have seen it a lot of times. Again, the question says the mass of the block is m. Again, the question is saying draw FBD and write the equations. If I draw FBD, one thing for sure, there is a weight of the body that is mg. It always acts in the vertically downward direction. One thing for sure. Another thing, there will be one more force that is normal reaction. Normal reaction, name is normal reaction. That means this normal reaction always acts perpendicular to the surface. So there is one normal reaction that is N. This normal reaction is perpendicular to the surface. These two forces are there. Now you can clearly see that these two forces are not in the same direction. Now we can resolve this. Let's suppose this angle is theta. This angle is theta. Now we can resolve it in its component. And what will be the resolution? This angle will also be theta. And this is the another component. So we are resolving mg in its two component. The theta is here. So this component will be mg cos theta. And this component will be mg sine theta. And this block will move. You can clearly see that this block will move in the downward direction like this. Like this block will move something like that. This is how you draw the FBD. Is it clear? Can you write the equation of Newton's second law? Here what we can do, we can assume our x and y axis like that. This is our x axis and this is our y axis. Now we can write the equations. I will write one equation for you. In x direction, how many forces are there in x direction? You can see that there is only one force in x direction, that is mg sine theta is equals to. Newton's law says F is equals to mass into acceleration. That is equation number 1. Now if I write in y direction, how many forces are there in y direction? This is our y direction. There is one force N, another force mg cos theta. N minus mg cos theta is equals to. Can this block move in the upward direction? You can say no, it will not move in the upward, it will just slide down the incline. So you can say this is 0. Now, what I think is, it seems a difficult topic for you. If yes, then tell me. Otherwise, I will move further. Just say yes or no. Uh, do you face any sort of difficulty in this, or have you studied that earlier? You are facing difficulty. Okay, Logesh. In class 11th, you didn't study this thing. Will the equation cancel out m in x direction? Yes, it will be cancelled. Very good. A will be g sin theta. That will be cancelled. Okay, okay, Logesh. If it's clear now, then we can move further. Now, another type is with pulleys and strings. Now, till now, what we have studied, a block on the horizontal surface without any force. Another thing is with some inclined force. Another thing is inclined plane, block on the inclined plane. And the last thing that we are going to study is the string problem. Whenever you see string, in general, this string is given as massless. And whenever the string is massless, what you should do, first of all, when we draw the FBD, one thing to be noticed, one force is always there. That is gravity. One is M1G, another is M2G. This force is always there. Now, can you see that will there be a normal reaction or not? Will there be a normal reaction or not? You can see that normal reaction is exerted by the surface. So here there is no surface at the bottom of the block. So that means there will be no reaction, no normal reaction. Clear? Now what will happen whenever there is a string? There is a tension in the string. The string will create, there is a tension in the string, and this tension is denoted by T. This tension is denoted by T. Now, for the string problems, what are the main points that is to be remembered? First point, I am talking about which string? Massless string. Which string? Massless string. First point, tension in string remains same. Tension in string remains same. What is the meaning of this? If there is a one string, then tension in that string will always be same. For example, you can see that this is one string only, which goes over the pulley and attached to the second block. If there is only one string, then the tension in the string will remain same. Another thing that you should remember, it acts in pair. Acts in pair means in a string, you should represent two tensions. That's what is the meaning of it acts in pair. Another thing, directed away from the point of contact. Point of contact. You can see that what I'm saying, it is directed away from the point of contact. You can see that this is the point of contact of the string. This is the point of contact of the string. So direct tension will be away from this point of contact, that is D, that is T. If I draw another diagram for you, for your reference, for example, I have drawn this diagram. Can you see that there is only one string in it? There is only one string in it. And what are the point of contact? This is a point of contact. This is a point of contact. So tension will be away from the point of contact T and T. And it will be in pair. That means you need to represent two tensions and always away from the point of contact. So is it simple for you to mark the tension in a string? Now, what if I say, I will extend the diagram and say, let's suppose there is one more string like this. Then now the string has changed. So in this string, again, there are 2 point of contacts away from the string, but this tension will be different. Let's suppose T2 and T2, because this is a different string, so tension will be different. I think clear now. Say yes or no very quickly, because these are the important things, and if you can get that, everything will be sorted. Respond very quickly. Very good. I think everything is clear. Moving further, all type of things are covered. Now there is a question, very simple question. Okay. Question says, two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a frictionless pulley. The acceleration of the system in terms of acceleration due to gravity. So what are you what can you see here? First of all, we need to draw the FBD. First thing is that, first of all, there is a weight. How much weight will be there? We know that weight is mg. So that will be 6g and that will be 4g. Clear? Now there are 2 point of contacts, one this and another this one. So there will be 2 tensions, T and T. Clear? Now, according to you, in which direction the block will move? This 4 kg block will move in which direction, upward or downward? I think most of you can clearly see that it will move in the upward direction. It's not necessary that always question will say that where the block will move. You need to identify it by yourself, because 6 kg is heavier. So this 4 kg will move up, 6 kg will move down like this. And both the blocks are attached with the same string. So acceleration of both the blocks will be same. And you need to calculate this acceleration only. Solution says, now what you need to do, you just need to write the equations. You just need to write the equations. For 4 kg block, if I write, how many forces are there in y direction? Only 2 forces, T and mg. So equation will be T minus 4g is equals to, what is the acceleration? We have taken A. What is the mass? 4. So it will be 4A. Clear? For which 6 kg block? For 6 kg block, if you write, there is a tension T in the upward direction. T 6g in the downward direction is equals to, again, mass into acceleration. Mass is 6, acceleration is A. Can you see that this acceleration is in the downward direction? And the downward direction is taken as negative by us, so it will be minus 6A. We have 2 equations. What you need to do, you need to calculate the acceleration thing. So you can solve the equations. You can solve the equations. How you can solve the equations? Put the value of T from equation 1 into equation 2. From equation 1, we can see that T will be 4A plus 4G. I am putting this value of T in equation 2. This is the equation, so you can use any method. So that will be 4A plus 4G minus 6G is equals to 6A minus 6A. Can you see that this is going to be 4A and minus 2G. 4A minus 2G is equals to minus 6A. So 10A is equals to 2G. A is equals to G by 5. G by 5. So which option is correct? G by 5, G by 5. Which option is correct? Option C is correct. Is the concept clear? Can we move further? Very good. Jairaj, very good present. Deep Shikha, is saying option C. Very good. Very good. Very good. Now we will move further about momentum. Now we will, there are some definition thing or some formula things that we will not take a lot of time. We will quickly wrap up the things here. What is momentum? Momentum is generally denoted by P. And what is the formula for momentum? P is equals to mass into velocity. What will be the unit? Mass is kg, velocity is meter per second. So unit will be kg meter per second. Another thing, it is a vector quantity. If it is a vector quantity, it will have some direction. So direction is nothing but the direction of velocity. The direction of velocity will be the direction of momentum. Clear? Okay. Again, momentum is clear. Moving further. What is impulse? What is impulse? Impulse is generally denoted by J. Generally denoted by J. What it says, when a large force or a force with larger magnitude acts on a body for a very short time, then this impact is known as impulse. And it is defined as J is equals to F into delta T, where F is the larger force and delta T is the duration during which it acts. So J is the, again, F into delta T. Basic simple formula. Now again, one more thing. There is an impulse momentum theorem. What is this? It says that impulse acting on a body is equals to change in the momentum. Impulse acting on a body is equals to change into momentum. Delta P is what? Change in momentum, or you can again write it in some different way, like J is equals to P final minus P initial. Clear? J is equals to delta P, P final minus P initial. Clear? Now we will move further. I think we have 10 or 20 minutes remaining, so we will do the remaining things. Concept test. There is a concept test on your screen. Question says a ball of mass 0.15 kg is dropped from a height of 10 meter. Read out the question. Okay. A ball of mass 0.15 kg is dropped from a height 10 meter. Let's suppose this is a surface. J and V is saying something. Is it vector? Is it vector? Are you talking about impulse or what? If you are talking about impulse, then I will say it is a vector quantity. If you are asking about impulse, then I will say it is a vector quantity. J and V. Now, listen to the question, what it says. Tell me if you were asking about this or any other thing. This is a ball of mass, suppose M. Mass is given 0.15 kg is dropped from a height h. H is given as something 10 meter. So we know the data. And it is dropped. What it says, strikes the ground and rebounds to the same height. and it strikes the ground and rebounds to the same height. Let's suppose what is the situation, it's coming like that, and it will go again to the same height, this one. The magnitude of impulse imparted to the ball. So whenever they are asking about impulse, impulse can be calculated by two methods. One is J is equals to F delta T. For this to happen, they must give us some force and some time duration. Okay, 1.4. Someone is saying 1.4. Option A. Who is saying that? Awesome, Reba. Okay, let's check. F delta T. Another thing that you can use impulse momentum theorem, that is J is equals to change in momentum. So which of these two is to be used here? I think you can clearly say that force and time is not given. That means this is going to be used here. Now, again, listen to me. When the ball reaches the ground at the time of impact or just before the impact, it will have some velocity. And from the kinematics thing, you know that the velocity just before reaching the ground after falling a height edge, its velocity will be 2gh root of 2gh. That's clear. And this velocity will be in the downward direction. In the downward direction. Again, just after the impact, it will go in the upward direction. And question says it will rise up to the same height. That means it must have the same velocity. That means velocity is again root 2gh, but this time in the upward direction. That means we know option C. Deepika is saying option C is correct. Okay, so there are two answers, 1.84 and 4.2. Let's check. So we know the velocity. So J is equal to delta P means final momentum minus initial momentum. If I talk about final momentum means mv final minus mv initial. This is v initial, this is v final. If I put the values, mass can be taken as common. V final is what? Root 2gh. Can you calculate this value root 2gh? Yes, we can calculate root 2g is 10, h is 10. Can you see this will be 10 root 2? This will be 10 root 2. So we will place the values. V final is 10 root 2 minus V initial is what? 10 root 2. In which direction initial velocity is? It is in the downward direction. It is in the downward direction. That means negative. So negative will become positive. Now put the values. If I put the values again of mass m, so J will be, mass m is 0.15 and this is 20 root 2. If you put the values, this is 3. 15.15 into 20 is what? 3. I think clear. Root 2. Root 2 is 1.4. So 3 into 1.4. That is 4.2 kg meter per second. So I think Deepshika has the correct answer, C. Very good, Deepshika. Clear. What's happening here? Option C is correct. Now moving further. There is one more question. This is an important question. Question says a 0.5 kg ball moving with a speed 12 meter per second. Okay. It strikes a hard wall at an angle of 30 degree with the wall. It is okay. Listen. First of all, draw it. What is it? They are saying that there is a wall like this, and a ball is coming and strikes the wall at an angle 30 degree with the wall. It is moving with some velocity v. Clear? After striking, it is reflected with the same speed at the same angle. That means after striking, it is reflected at the same angle, like this. If the ball is in contact with the wall for 0 point, that means time is again given. The average force acting on the wall is asked. That means they are asking us the force. Time is given. So first of all, what we need to do, we need to calculate the impulse. And impulse is what? Change in momentum. Impulse is what? Change in momentum. So first of all, we need to calculate the change in momentum. That's what we can do here. Okay. Now listen. Let's suppose it has a momentum P. Mass is given, velocity is given, so you can calculate the momentum, that is P is equals to mv. P is here. In this situation, P will be here. Arrow, in the direction of arrow, I will say. Now, what is the change in momentum if I talk about? In general or in the previous question, what we have seen that one time ball is coming in the downward direction and after striking it is going in the upward direction. Can you see that both these velocities are in the y direction? Both these velocities are in the y direction. Now in this question, no velocity is in the y direction. They are at certain angle. So I told you whenever there is angle, the involvement of angles other than the x and y, you need to divide, you need to component, you need to resolve it in components. So what we are going to do, we will resolve its components. This is our x-axis, we are assuming it. And definitely this is going to be our y-axis. This is x-axis, this is y-axis. So first of all, we will divide its component. If you can see like this momentum P will have a component in this direction and in this direction. This component will be P cos 30. This component will be P sin 30. Clear? This momentum P will have a component. I will write it with different pen. Like this P will have a component in this direction. This is angle also 30. This component will be P cos 30. And this will be P sin 30. Now we have resolved the components. Now you can see we will calculate the change in momentum in different one in y direction, one in x direction. So if I talk about delta P in y direction, what it will be? P final minus P initial. Clear? You can see P final. Which is the final momentum? This is final, this is initial. That is P cos 30 minus P cos 30, that will be 0. That means there is no change in momentum in y direction. Clear? Now, in x direction, if I talk about delta P in x direction, this is x. Again, P final minus P initial. If you see, that is P final minus P initial. And if I place the values, what is final momentum? This is final momentum. That is P sin 30. In which direction the final momentum is? It is in the left direction. So there is minus sign. Minus is already there. And P initial is what? P sin 30. This is in the positive direction. That is P sin 30. Can you see that it will be minus 2P sin 30? What is the value of sin 30? Is it 1 by 2? Is it 1 by 2? Sin 30 will be 1 by 2. 2 and 2 will cancel. So it will be P. So delta P in x direction is what? P. Now, according to impulse momentum theorem, from impulse momentum theorem, J is equals to delta P. J means F delta T is equals to delta P. If I put the values, F is equals to delta P by delta. Delta P is what? That is minus P divided by delta T is 0.25. Now what you need to do, just put the values of momentum. Momentum is what? Mass into velocity. Mass is given as 0.5. Velocity is given as 12 divided by 0.25. Now you can solve it. It will become 24 Newton. If I divide it, it will be divided by 2 times 12 into 2, 24 Newton. So F is what? 24 Newton. They are not interested in directions. They are asking only the magnitude of force. That's why I have not placed a negative sign. Otherwise, you can place the negative sign here. And with this negative sign will indicate the direction only. So what is the correct answer? Option number, you can clearly see which option it is. It is C option. Now, this type of question most of the time is asked only for the calculation of change in momentum, like this. Only for the change in momentum, they have asked this question. This part is extra part. Clear? Moving further. What is friction? It is a force caused by the contact of two surfaces and tries to oppose the relative motion between the bodies. The thing might be something very difficult to you to understand. For example, there is a body placed on a surface. When these two surfaces, one is the block, other is the ground, they come in contact. Due to this contact, a force is created, and this force is known as frictional force, or generally it is known as contact force. It will be a difficult thing if I tell you that contact force has two components. One is normal, one is friction. So don't go with that. You just remember that friction is created by the contact of the two bodies. This force is electromagnetic in nature. Electromagnetic in nature. Again, what are the types of friction? This is again important. You know the types: static friction, kinetic friction, and rolling friction. What are the two important types here? Static and kinetic friction that we will study. Listen to me very carefully now. Static friction. Let's suppose I'm doing it in a very good pace now. Sorry. Let's suppose this is a very heavy block. Very heavy. And the surface is rough. And a person is trying to push that block. He is applying some force. But you can see that when the block is heavy, if you apply forces, it will not move generally. And so the block is not moving. You are applying some force F and the block is not moving. That means someone is opposing your force. Because what's Newton's first law? If there is a force, there must be acceleration. So there is a force F, but acceleration is zero. That means there is someone who is opposing your force, and that someone is nothing but the friction. And which friction is? Static friction. That means if you apply a force on a body and it's not moving, in that situation, the friction is static friction. Friction is static. Generally, we denote the friction or whatever the friction it is by small f. Now, can you see that if I increase, if one person is more added to the group and he is also applying force, what we can see, he is also applying a force F. The body is still not moving. That means this friction is able to counter both these forces. That means small f and friction is equals to 2f. If I apply one more person, he is also applying force. And now the body starts moving. That means now the friction converts to kinetic friction. Friction converts to kinetic friction. So what are the important points about this static friction? One important point, it is dynamic in nature. Dynamic in nature. What is the meaning of this dynamic in nature? Meaning is its magnitude depends on applied force. Depends on applied force. How much force you are applying, it depends on that. Another important thing, maximum value of static friction. Static friction is F S max. That means static friction, the maximum value of static friction is mu times the normal reaction. Mu times the normal reaction, where mu is what? Coefficient of friction. I think you know this term, no? Coefficient of friction. What is to be remembered? It is a dynamic force. It changes according to the applied force, but it has a maximum value. And this maximum value of static friction is what? Mu into N. Clear? What will be the direction? Direction will be such that it will oppose the relative motion. So it is very easy for you at the NEET level to identify the direction of static friction. Now, kinetic friction. The same thing is with kinetic friction. When body is moving, then the friction is known as kinetic friction. What is its magnitude? Kinetic friction is not dynamic in nature. It has same value, and that value is mu into N. Or you can say coefficient of kinetic friction into N. And in this case, you can write as coefficient of static friction into N. One thing to be remembered again as a punchline, that always mu static is greater than mu kinetic. Now we will do a question so that you can understand it better. Question on your screen. This is an important question. Previous year question as well, you know. Okay. So we will end the session after this question. Try to solve it. The coefficient of static friction between A and 2 kg block is 0.2. That means coefficient of static friction is 0.2. This is given. What would be the maximum mass value of block B? Let's suppose its maximum value is M, so that the two blocks do not move. If you have studied the question, what I'm saying, I'm explaining the question. You can clearly see that this 2 kg block is here and a string is attached with mass M. If you can see that in general, if friction was not there, if this friction was not there, then this 2 kg block will move here. So they are asking us, due to the friction, this block is not moving. So they are asking what maximum value we can put here so that it cannot move. So let's suppose first of all draw the FVD. This will be mg. This will be 20. There is a normal reaction. There will be a normal reaction like this N. And there will be a tension. How you can identify the tension? The string is same. There are two contact points. One tension is away, another tension is also away. Now we can draw the FVD. You can say that one more force will be there, that is going to be friction. In which direction friction will act? It will try to oppose its motion. In which direction 2 kg block will have a tendency to move? It will move in this direction, but friction will oppose its motion. So this is friction. Now we can write the equations for M. I am writing the equation. T minus mg is equals to 0. That means T is equals to mg. Let it be equation number 1. For 2 kg block, if I write, there are two forces one is tension, another is friction, is equals to. It is also not moving. It is also not moving, that is 0. That means you can again say that T minus, what is the value of friction? What is the value of, or the maximum value of static friction? You see that it is mu into normal reaction is equals to 0. T minus mu into normal reaction, you can see that N is equals to 20 is equals to 0. Now I will place the values. T is what? Mg minus, or you can say it, if I transfer it here, it will become equal. Mu is what? 0.2 into 20. N will be equals to, it will be 4 by G, that is 4 by 10, that is 0.4 kg. 0.4 kg means option D is correct. Correct. One more question for your homework. This is for your homework. If you were not able to solve this question, then please ask me in the next session. I will explain it to you. Otherwise, take a screenshot. It's on your screen. And I am ending the session. Bye, everyone.